Okay, I found it. Let me give me a notation. Give me a notation.
How do I do that?
In your Zoom menu, allow annotation.
Okay, I think you can. Yeah, you can annotate now.
Sorry, I was up. Yeah, click the wrong. Annotation. Your Zoom menu, please. Your Zoom menu. Your Zoom
Oh wait, no,
menu.
I allowed it already.
You allowed it. You allowed it. Thank you very much. Yeah, sorry, I was out. I cannot annotate. I cannot annotate. Try again.
See.
Where is? Yeah, I cannot see it because it's above the camera. Where's
Did I share my screen? Look at the screen share.
The screen share cannot show this menu. Zoom menu does not appear in the screen share. It's very weird. Oh yeah, you already enabled the annotation. Okay, I got it. Thank you very much. You got it. So this guy, there you go. You see that?
Oh.
That share with me. You click that. Yeah, and the set one math. Yeah, that folder. Yeah, this is the easiest way to find it. So next time you'll find it this way. Okay, please click that. Okay, right now it's time for you to select one. Which one do you select? Okay. So Arya, you select which one? Bukit Merah, is it?
This one. Bukit Merah.
Bukit Merah. Okay, I'll follow you there. You start collecting them, right? This is 2015, right? Yeah, right. So I'm there also. Question one, don't have it. Okay, come. Let's scroll up. Question. I don't think I am. Oh, I did wrongly. I should be doing the SA2. So. Okay, so question one though, right? Question one, question two, question three, question four in put it in the Jamboard. This is how you screenshot? Okay. I guess that worked. Jamboard. Well, this is not very difficult. This guy is also not very difficult.
I mean,
Well, I'm looking at the questions and they really don't look difficult at all.
it's not getting copied. This one.
Press the copy button is the.
Yeah, see, I can't paste it back.
No. You didn't use the method I suggested. The method I suggested is the Windows Shift S. You don't even need to copy anything. You can just paste. It usually works.
Know, but the problem is, I am not in my keyboard. I am using iPad mode.
Yeah, just flip the keyboard. Right? The keyboard is behind. Right?
Yeah.
Click the keyboard. You can click the keyboard just for a while, right? After this question, then you can just put it back, right?
I'm okay with doing work like this. It's just
Yeah, I know. I know. It'll disturb you. Just do the keyboard for now, and then you'll be happy, right? Right? Come. Let's do it the easiest way, right? And the questions are also not very hard. Some slightly challenging ones. So percentage are also not in the exam, right?
no.
Okay. So how's your Windows Shift S and then Control V pasting? Good, good, good. Right. Obviously there's 6, right? Pasting. Uh, no more for paper 1. So I think we should go to paper 2. Paper 2, question 2. What do you think? Question 2B lah.
Yeah.
Are you pasting 2B? Oh, yeah. Right. 2B, and then 3A. And then what do you think about question 5? There's 5 in. And lastly is, yeah, 5. Oh, graph is also not yet. Wow. Okay, so 2, 3B, 5. And then just to confirm, question 9 is not in line.
Uh, somebody's scrolling.
Sorry.
Oh my god, it's gone. Oh my god.
This is giving you a lot of trouble, isn't it?
No, the thing is auto scrolling. And it's gone.
Okay. Oh, ratio is in. All right. Okay, sure. Ratio is in. Still having trouble.
It's loading.
Question,
The
okay.
file isn't opening.
Okay. Question 5 is it? Question. Oh,
Yeah, I can't access it. Oh wait, no. Question 5. No, question 5 is not tested.
uh-huh.
It's still I mean, algebra as in like equations, not usage in like graph. I mean, not usage in graphs or
So
diagrams.
question 9 not in, and then question 5, just to confirm.
Question 9 I think can.
Question
But
9
like
can.
if there's like something like if it's using a triangle or a circle, then it's not tested.
So 5 is not in. 5
Question
is not
5,
in. Yeah, it's not in.
yeah, it's not it. Question 5 is not it.
Wow, your exam is very restrictive. I don't know whether it's a good thing or not. Okay, sure. I guess that's good. We have so little questions. Question 9 is like totally graph drawing, and you say that graph drawing is also not in.
Oh no,
Right?
question 9 is in. Question 9 is in. I'd say question 9 is in.
Okay.
But question 5 is not in.
Sorry. You say that question. You say that graph drawing is not in, but how come
No, like
question
I
9?
meant graph as in wait, I show you a photo. Wait.
I mean,
Uh,
if it is in, good luck. Then we can write. It's good.
yeah, like something like this.
Did you put anything somewhere? Sorry, I cannot see. I cannot see much.
Uh, you see this like
Oh yeah,
this?
yeah. Okay. Oh, you mean that kind of graph is not in lah?
Yeah, like
Okay, I
these kind of
understand.
graphs.
Okay, I understand the statistics graph. Okay, I understand. Okay. So we have collected all the questions lah, right?
Uh-huh.
As per usual, total the marks and order it the way you like it lah. Do you want to
Okay.
do graph first? Do you want to do graph last? Do you want to do certain things first? Do you want to do certain things last? Totally fine with me, but order it the way you like. You don't do things based on their number. No, 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 no.
Okay.
Okay. Once you're done, you total the marks and then time for discussion. Lah. We discuss first, anything happy, la, 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 la. Then we start doing.
Wait, can I go to the toilet?
Yes, please.
Okay, thank you.
Yep.
Okay, I'm back.
Yes, Arya, I can hear you. All right. So your ordering is like that. Okay, it's number one. Oh, that's the total marks. Right. So we have 21 marks, right? Oh, by the way, do you know how many minutes is the exam?
45, I think.
45. Have I told you 45 minutes means 30 marks?
Yeah, I mean,
All right.
I don't
Yeah.
know. I'm just estimating here.
Right, right. Understood. For this one, this will be around 21 marks, right? 21 marks. So, I mean, it's okay. No problem. We cannot find any other question anyway. Right. So, yeah. Now, how about your ordering? And uh, let's try to discuss.
Um, I guess, I mean, I don't need to discuss. I'll just, I mean, to me, algebra is algebra. I don't need any ordering. I'll just do them one by one.
Understood. Understood. The question does not worry you, lah, is what you're saying.
Yeah.
Anything else that worries you? The graph, the ratio,
No.
right. Then, since this is 21 marks for our practice, it will be 21 minutes, right? 21 minutes. Please set your timer, and by the end of 21 minutes, we're done. This is not designed to make pressure, a life pressure for you. No, this is all the discussion and the ordering is designed to make it much easier.
Okay. I'll start now.
All right. You have your timer yet? Okay.
Uh-huh.
Sure. Please do that. I think, sorry, did you want to do it on your tablet or on a paper?
I'm not using a tablet. I'm using my BLD. It's the same.
Okay. All right. Sure. You don't have to use the keyboard now, Arya. Like, you can just write, right? More natural for you, right? I think typing will slow you down. I think writing on paper is the best. But if you want to try, you can write on your PLD lah. But I would strongly suggest not using the keyboard. It's it's very slow. It's very slow. You don't handicap yourself like that. And I would like to suggest that you can use paper lah. So normal lah.
My
But
PLD is lagging.
yeah, why don't you
It has delayed
just
response.
yeah, why don't you just flip the keyboard back and just use paper, please? Much better. Right? Much better. You're under time constraint, so you don't deal with all these technical problems and typing. It's very bad. Please don't. Pause your timer, flip the keyboard, get a paper, come.
Oh wait, no, it's back. Okay. I still have 16 minutes left.
I know, but typing is not going to help you, okay? Typing is
Yeah.
right. So flip your keyboard, please. Flip your keyboard, take a paper, all the stuff. Don't handicap yourself. Don't.
Okay. I mean, flipping it will take time. Not waste. Use it.
At this point, you don't have to worry about showing me your video of working because when it's exam training and you're doing it, I don't follow, right? I only follow where we are in discussion, right? So you don't have to worry about that also. Okay, writing here is fine.
Teacher. Hello? 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 Excuse me.
Oh,
You
yeah,
mute.
you're saying, sorry, I'm muted. Yes, you're saying?
Uh,
You're
this
saying?
one is
Yes.
on graph. This one is on graph paper,
It
so it
is. It
won't be
is on
tested.
graph paper. Correct. Yeah. Are
Yes,
you
right.
saying that? Uh-huh.
It won't be tested. Yeah.
So it won't be tested. Okay,
Yeah.
yes. It is on graph paper. Yes, it is. It is. So no, not tested yet.
Uh-huh.
All right. I guess we are done then.
Yeah.
All right. Okay, sure. Why don't you check the answer key and then you have your marks, right?
Wait, 55 is to 88 simplified is 5 is to 8, right?
I'm sorry, 55 to what?
Is to 88 is simplified is 5 is to 8, right?
Correct. You mean you didn't simplify, right?
Yeah, I didn't.
Oh, goodness me. You lost the 1 mark
Oh.
because of you didn't simplify. I think the first one is fine. The first one, I don't think you can simplify, right? The second one, you lost the 1 mark. Even though you are not wrong, but you are also not right.
Wait, which question is this?
Are you saying?
I'm trying to find the question which I used. No, where's the question?
You mean you're trying to find the number? The number is there, the Jamboard. Number
No.
4, number 6.
Yeah, one of the question I didn't put.
It's number 2, I believe.
Number 2.
Check number 2 or number 3 lah. So check. It only
Oh, yeah, it's still B. Right. Thank
it will be
you.
right. No problem.
Huh? Wait, it's wrong.
Yes.
The answer is wrong.
Okay. Which one is wrong?
Wait, what? Hold on. Yeah, the answer is wrong. You see over here, it says 2x plus 5 when it's meant to be just x plus 5. So they got it wrong.
Okay, wait, huh? No, 2x plus 5 is correct. You are wrong.
Huh? Why?
No, you're wrong. You're wrong. You're wrong. In this case, I think you still have something to learn.
No, you see
This
over
is black pen. This is twice.
pink pens, right? So this is one pink pen, this is another pink pen.
Twice the cost of a black pen. Your part 1 is wrong.
Oh.
Your part 1 is wrong. So therefore, your part 2 is wrong.
Oh.
Your 3 marks is gone. Your 3 marks is gone.
I see.
That, well, you should be a bit worried. You should be a bit worried.
Yeah.
I think that's it. Is it? Wait, yeah, I think that's it, right?
Oh yeah, it's relationship then ABC.
Oh, you mean the part 1 is also wrong? Oh, oh yeah, yeah. It should have been 10. Nice. Yeah, yeah. Oh, wow. Yeah, that's a very slight mistake, but I don't think they will let it go lah. Ayo.
Yeah, okay. Done.
Right. So, oh, the part B is also wrong. Yeah, right. Glad you had some of them right. Glad. Okay, this is not the 100% that we experienced last time. Definitely not. Yeah. Um. Do you know the mistakes that you make then? As in, do you understand them?
Yeah.
Okay. Then, if there is nothing else, I mean, just nice like 8:30. Uh, I won't ask the marks. I think we learn a lot lah. I think we learn a lot here. Let's do better on Tuesday. We'll do the exam training again. Just same thing, right? But of course, first we will do the homeworks or the questions that we have. If not, we immediately go to exam training. All right.
Okay, bye-bye.
Okay, I'll see you on Tuesday. Bye bye.
Hello.
Yes, hello Daniel. I can hear you.
All right, let's go. So, what do you want to do today?
I usually ask you that question. How is math?
Okay.
How is math? Last time, we were ahead of the class, like right? Always a good thing. How is it right now?
We're still ahead of the class.
How far are we? How far are we ahead?
He hasn't started binomial yet.
Right. Okay. All right. If it is possible, we go even more ahead. That's one option. All right.
Sure.
If not, then we go and discuss past stuff. That's also possible. Or we also can discuss another subject. But as per usual, you know yourself. You must decide.
Yeah. I have some physics questions.
If you want to talk about it, I guess it's a good idea. It's a good time.
All right. Okay.
Elliot and Yoko, I can hear you. Yeah. I can see you. Yeah. Can you hear me?
Yeah.
I'll use the
good.
physics Jamboard.
Sure thing. Elliot, can you hear us?
Yeah.
Okay, cool. Brian, today I will ask you to be with Kyoko, yeah? Kyoko, you will be with Kakak Brian today.
Oh, okay.
Brian, in case there's other updates, please update yourself with Kyoko. Last time we meet, we are not at integration yet. Last time.
Yeah.
So Kakak Brian and Kyoko. Elliot, if you could update me, I will see you in the chat board. Daniel, physics will be, is it physics 1, Daniel?
Yeah, physics 1.
Okay.
Page 11 now.
Okay, I'll go there. Elliot, when you have the new Jamboard, please tell me. Yeah.
Okay.
Guys, today I am a little bit sick, so it's not the voice now. It's more like an infection, fever and everything. So I think I can still teach. I've been teaching for 2.5 hours, right? I think I can still teach today, maybe just a bit blurry. If you notice that I'm a bit blurry today, that's the reason for it. Okay, so I am looking at your page 11, Daniel. I'll make it bigger, okay? Yeah, I'm waiting for it to be nice. It's I can't read it right now. It's very weird.
I resend the Jamboard.
Okay, got it. I will now enter. Okay, Daniel, just to check on your side, the picture is nicer because on my side, I totally cannot read it. Like it's still, it's like very low resolution like that.
For me, it's perfectly fine.
Okay, then I'll wait for a little. Okay,
Want me to send you on WhatsApp?
No, done. It's done. Okay, nice binding energy, all those stuff. So no more quarks and everything. I'm waiting for the quark question and it's not coming. Okay, this is nice. It's nice. So what is your question, Daniel?
I don't know how to do any of these questions.
All right.
Maybe question 3, maybe I can do. But question 1, 2 and 4 are genuinely confusing. I think it's something that I don't understand.
Maybe possible. I'm going to read question 2 for now. Yeah. Okay. So let me confirm a few things. Okay. Partial fraction. Okay, got it, Elliot. Okay, so today, homework or something else?
Maybe, yeah, can do homework.
So no exam syllabus lah.
No.
No exam. Right. You're not making things clear, isn't it? Don't like it. Not even exam dates.
I think I got exam days.
Have I asked you to put it here? Exam dates?
No.
Okay, could you please put it in? At least we know the dates, lah, right?
Okay.
Okay,
Do
then
I-
let's go to homework.
For what?
I'm sorry, you're saying?
Do I type it in?
You can type it in, you can take a picture, anything goes.
Okay.
Okay, Daniel, let me just confirm that you know what's nucleon. Nucleon. So question 2 lah. Nucleon,
Yeah.
All right, so-
the nucleus.
which is to say it's only made of two things lah. So they are
Proton and neutron.
totally great. And he said average binding energy. Let's say you don't know what's binding energy. Yeah. If you do, then that's great. But let's say you don't know, the word average can still be understood lah, average. So average binding energy is 7.5 and the nucleon is 15. There's 15 nucleon. Correct.
Mm-hmm.
So the total binding energy, whatever that is 15 times 7.5 lah, right? I mean,
Oh, is that easier?
that's not no, that's not the thing for.
That's 112.
But it is true, isn't it? Sorry, it is true. It is true. It's
The
true.
answer would be C.
I think so because they round it off, right? It should be 112.5,
Yeah.
right? 112.5. Yeah. So it all boils down to it may. Yeah, okay, got it. So it boils down to what you understand about binding energy. I guess that will help. Do you know what binding energy is? I don't mean definition. I mean what you understand. Yeah, I got it, Elliot.
Energy required to hold the nucleons together.
Okay, let's see. So holding, right? So you're saying that you're holding it, or if you're holding it together, you require energy. Now, let me test that understanding. How come then he say to separate, you require energy? Holding and
Right,
separating are, the two opposite things, right? So holding require or separating require?
I think holding.
So if holding is required, let's say that's correct first, yeah. I mean, only when we do experiments, then we understand it. So fair, we cannot do the experiments. We can only, So when you hold something together, it's like when you're tying a pencil with a rubber band. It feels like the rubber band is holding the pencil, right? Right. So separating them should be easier. You just cut the rubber band. That would undo the energy holding it, and therefore the pencil is no longer being held together. Makes sense, yeah? Like it's almost as if holding something together is tying them, and releasing them would be easier. That is totally the opposite of nucleons. Like totally. Them being together is easy, and separating them will be very hard. It is almost like a magnet instead of tying something together. They go long and short in how to explain this, they go long, but that's basically the meaning.
Because nucleons are all together in one tight space, right? And
in one tight space?
Yeah.
You would think that means they require energy, right?
And because they're all the same charge, right? They're all positive charge.
Protons are positive charge, correct. So it requires overcoming. Correct,
so it requires some energy to overcome the repulsion.
Repulsion, correct. And you will be right to think about it. You will be absolutely right to think about it. So how come holding them is not difficult and separating them is easy, right? Right. Holding them is difficult. But there is something called the strong force. Have you talked about the strong force?
No.
Right. That means you just have to believe me at this point. No, it is very difficult even to show experimentally, but at least experimentally it is proven. That one you have to take my word for it. Once they go very close, you would think that they repel each other, but strong force comes to play. They call it strong force because it's very strong enough to overcome the positive repulsion. But strong force only works at extremely close distance, the kind of distance you see in nucleus. If this sounds like fairy tale, I'm so sorry. It is very difficult to even do the experiment in front of our eyes, but this is true. The strong force is the answer to the positive repulsion. Once you get the strong force, which ties them together, separating becomes harder. Staying together becomes easy, despite the fact that there's positive repulsion, which you have brought up as a very good point.
Okay. So therefore, binding energy is the amount of energy that's released, not the amount of energy that's required.
Let's see, yeah. So binding energy, right? So the word is very misleading now, I remember, right? Okay. So think carefully about our concept in mind here. Arya, this is partial fraction, right? Correct, yeah?
Yeah.
Correct. Do you know how to start?
Yes, I think I do.
Okay, let me see how you start. Let me see how you start. So Daniel, can you accept now that staying together is now easy? Breaking them is difficult.
Mhm.
If breaking them is difficult, that means that it requires energy, no? And staying together does not require energy. It releases energy. The word binding energy is, in some sense, I still feel until now it's a bit misleading. It almost gives you the hint or the meaning that to bind requires energy. That is so not true. When you bind, you release the energy, which is an expression to say that you don't require energy. You even give away energy to do it because it is so easy to do. Now, with that in mind, we'll be using that concept for quite some time. So, Elliot, I would like to address the starting point. I think your starting point has some logic. However, this is the weird logic, right? Would you try to do question 3 then, Daniel? No. What you're doing is correct, Elliot. Yeah, definitely correct. I can simplify this to this is what I'm trying to say. And some teacher will teach it this way, right? I also feel that this is slightly easier, but what you're doing is not wrong in any way. So if your teacher teaches you that, I'm totally fine with it. But
like my teacher say like do like this, right, like this.
So what you wrote lah?
Yeah.
Okay, then follow him first. Follow him because anyway, if you simplify that, it becomes this. So I have no complaints about that. So you do you for that.
But what's the difference?
Oh, it's just like actually I can't even say that it's slightly easier. Actually, no, it'll probably be okay. As for differences, they're not different. They're exactly the same. Why? Because it looks like this one: ax equals x squared plus b over x squared. Correct? Then it becomes like this, right?
Yeah.
Right. So they are exactly the same. So I have no complaints. You just do what your teachers do. No problem.
Okay.
Okay, Daniel, what do you think about part 3?
Is it D?
Okay, lowest to highest. Oh goodness. Yeah, that word again. Okay, you think about this for a while. Obviously, the X will have a lot more nucleons. So nucleon number I'll just pretend, okay, this is nucleon number 200, okay, just to give us a guideline. And for some reason, it's split to 81 and 119, okay, for some reason, okay. Is this okay, Daniel?
Yeah.
All right, so this is 200, this is 81, and this 119, right? Okay, for example, right? This is all possible or no? This is okay. So the word binding energy per nucleon is the same as average binding energy, which is what you found in question 2. I just want to clarify that first. Would that be okay? Right. So binding 200, because binding energy is the energy release, right? Because binding is such an easy thing to do, not a difficult thing to do, then binding 200 will not be equivalent to 81 and 119, even though both are 200. So binding 200 will release even more energy, right? So in that sense, X should have the average binding energy. Because the more you, let's say the nucleon is only 2, right? So now this is binding one proton, one neutron. Let's say, let's just pretend. Okay. Okay. Then this is the you can see the binding here, right? Binding here, right? I think that is that kind of visualize the energy release. I'm totally making this up, but when you bind, you gotta release some energy, ma. So there you go, lah, right? Okay. You release some energy, lah, right? Then if I bind more, this is N. So that. Okay, release more and more, right? Okay. The more things you bind, the more energy you release. That's not a surprise. But look at the average lah. So when I only have two, it's one binding energy, one overlap over 2 lah, right? But when I have 4, I have 4 binding energy over 4. So the average does increase lah. If that makes some sense. I'm trying to explain this in the simplest way possible.
Yeah.
There you go. So if you have 2 nucleons, then the binding energy average, right? Average binding energy is 1 over 2, lah, right? But this one, average binding energy, it can be 4 over 4, which is 1. So higher average lah. Will this be okay first? Then? Okay, so by this logic, then 200 will be having a very high binding energy compared to 119 compared to 81. So only by that logic, then it will be X, Z, and then Y instead. Now, I'm going to tell you why this is wrong. This is wrong. Okay, your answer is actually correct. I think because you've seen the graph, right? Okay, so time to explain the graph. In your lecture note, you should have a graph, something like this, something that looks like that. And in the middle here, there's a 56. This is average PE. If you answer this without any knowledge of the graph, then you are lucky that you're correct. But if you have remembered this graph and you answer this question using it, then you're good already. You understand. You understand the whole physics. The graph kind of summarizes that. Yeah, it looks good to me, Elliot. Definitely looks good. Yeah, your techniques are fine. So Daniel, do you know the graph that I'm talking about?
Let me go see.
Yeah, you may want to look at your lecture.
No, there is not.
Okay, no, this not okay. They will base many questions off this. So unless I'm wrong and your lecture note really don't have it, then I'm totally happy with it.
It just gives me E equals mc squared.
No. Would you mind just sharing the screen? Yeah, we'll just look at it together just to make sure that we're not missing anything. All right. So Elliot, doesn't mean that it cannot be zero, right? Currently, your answer is A equals to 0, right? It can be 0. It can be. It can be 0. Do you know how to confirm your answer without the answer key?
No.
But I'll show you. Just a minute, Daniel. Give me 1 minute. So currently your answer is A is 0, right? What is B? B is 7 and C is -2, right? Okay. So you're saying that this is equals to that. That's what you're saying, correct? This is equals to that, right?
Yeah.
Now you set x to any random number. When I say random, I mean the most random one is set x equals to pi using a calculator. Can you do that? So you set x equals to pi and then you type in the left-hand side and then you type in the right-hand side. If both are the same, then you're correct. Look, the 0 shouldn't bother you. Understand?
Okay.
Okay. So it will be nice to read exam. Okay. Not this one. Yeah, so not this one. Daniel. Okay, let's scroll down. Oh, there you go. 2 pages after that, that's the graph. 2 pages after that, that's the graph that I mean. There you go. There you go. This one.
Okay.
Whether you memorize this or not, I'm gonna put it in the next page. We'll check out page 12 with me, Daniel. So I will just consider the peak to be 56. There's a lot of discussion whether it's 56 or 58. Yeah, we shouldn't care. I'll just say that the peak is 56. This is the peak of binding energy per nucleon, which is called average also. It's average binding energy per nucleon. Right? Average binding energy. So from 2, 3 proton nucleon number up to 56, the average do increase, right? The average do increase. What I told you just now. From 1 to 2 to 4, it does increase on average. But for some reason that they don't discuss a lot, I think, starting 56, the average drops down again. So why does it matter? Because your 200 is around here, your 119 is around here, and your 81 is still around here. So if this is 200, 119, 81, which is the numbers that we make up, that means your original answer is correct. No? Okay. The problem is we don't know whether it's 200 or 81 or like we don't know. Correct or not? We don't know. It's just a number I made up. What if it is 56, right? If this is 56, then let's say this is, I don't know, 26 and 30, then what we say based on the graph is also already not true. Are you okay are you following so far, Daniel?
Yeah.
Right. So for the last piece of the thing, I'm explaining to you the whole chapter. For fission, it's always super heavy stuff. When we say super heavy stuff, think uranium, no? Uranium is nuclear number 238. There you go. And when you fission that, you almost get the very similar ratio kind of number. It's not exactly half-half, but it's similar. So my example kind of illustrates that. If you fission 200, you'll get a rather similar ratio. And you're usually fissioning something even higher than 200. So my example
Can you
stands.
explain what exactly fission is? Sorry.
Goodness me,
Not
right?
very
So
clear.
we need to talk about your technology. Okay, Jasmine. Elliot, how is it? How is it, Elliot? Oh, it's correct, is it?
It's correct, yeah.
Then you can be at peace, right? Okay, let's look at your lecture note, Daniel, and let's scroll up a bit. Scroll, I don't know. Let's see. When was the first time they talk about fission? It would be nice. Okay, Forster, sure. They talk about all this thing. So the picture here is fission law. Okay, maybe I'll start from the picture. Okay, go down. I think 5 pages down. 5 pages down. Goodness me, they don't make it easy for you, isn't it?
Down here, solving problems.
Almost here. Almost down. Hey, where's the picture where you shoot out? When you shoot the uranium.
It's below where it's below this part.
No. It's the picture. Huh?
Yeah.
Okay. I guess that this is a good thing. I mean this is correct lah. This is correct lah. There you go. I mean, this picture is fine. So this picture kind of illustrates fission. No? Fission is breaking apart anyway. That's what I mean. Fusion is recombining stuff lah. Is this what you're asking for?
Yeah, so fission is the opposite of fusion.
You can say it that way. Yep. Like the end result is opposite, right? Elliot, your starting point looks fine to me, like really fine. Looks really right. So if this is your question, then that's it. Okay?
Yeah, okay.
Okay, right. So I'm curious about question 4, fusion or fission? Question 4, fusion or fission?
Fusion.
Agree with you. So you already have an answer, right? So the answer will be fusion. If there is any other answer that you would like to think, it's not. Yeah, it's not alpha decay. It's not alpha decay. It's also not neutron capture. If you're confused, just I would pretty much like to refer to the slide also. Put it this way. Neutron capture means no. It's not the way it is. It's not. This is also not neutron capture. Very good.
Is it not my backspace now? Okay. No.
Yo, what's happening right there? Neutron capture is just what you see in the fission chapter. No? Vision pack. Oh, what's going on there?
I'm typing the P.
Oh,
P,
wow.
I can't type the backspace as well.
That's so weird. You can just restart everything. Shouldn't be something permanent. Shouldn't be. So as for neutron capture, it is something that you see in the fission page. That's it. You will go back to the fission page, then you will see neutron capture. Not this one. There.
Yes.
Question A is part A is neutron capture.
It's absorbing a neutron.
Yeah, neutron absorbing lah. Feel free to write things down, and then once you're happy, then let's go to page one, question one lah.
Okay. Question 1.
Are you stuck, Elliot?
Yeah.
You're confused as to what to sub in next. Am I correct?
Yes.
But from your previous work, you seem to be able to sub in just x equals to 1, like seemingly out of nowhere lah. Correct?
Yeah.
Why don't you do it here? As in, I really ask you. I'm very honest with the question. There's a reason why you're not doing it here. Do you know why? Why are you not just subbing x equals to 1? Because last time it works, right?
But that one, I'll find out one unknown. This one, I'll get 2.
2 unknown. That is the correct problem. You know the problem. The solution is very simple. 2 unknown, 2 equation, no? Do you get what I'm saying?
No.
You sub in x equals to 1, you will get 1 equation, but 2 unknowns, so cannot solve. Sub in another x, no?
Then what? Simultaneous equation?
Yes. Does that surprise you?
No.
All right. Then give it a try.
Okay.
Give it a try. Okay. Experience. Daniel, are you okay? Are we okay?
Yeah.
Right. So when you're ready, or if you want to ask any question, please do. But if you're ready, we go to question 1.
Okay. I'm done. Question 1 is asking. Wait.
Is that graph what we just saw?
I think it answers question 1.
Yeah, average binding energy, right? Which is what this graph is showing, like the energy per nucleon, same thing, like average binding energy.
Mm.
If you think that you'll forget that, might as well write down, but if not, then good for you. The answer is not directly. You have to understand the topic lah. So I guess it's a good question. The graph, however, is correct. No? Yeah, you have to understand the topic to answer question 1. I guess that's a good thing to discuss.
It can't be A, because radioactive decay can happen to everything, right?
Actually, no. Wait. I'll say it very clearly first. No, actually, no. No, actually, no. So I'll show an example of steel, 56 steel, right? 56 Fe. the steel that you're using in your chair and your table will never decay, because when it decays, it becomes radioactive. You don't want radioactivity on your chair and your table. That's one. But secondly, it is because steel is not radioactive anyway. It's not. So there's a lot of things in our life which is not radioactively decaying. It's not. So not everything will be radioactive, but you can, I suppose, make something which is not radioactive into radioactive. I guess you can do that. That one you can. But in its natural state, not everything will be radioactive.
Okay.
But you're correct that question A is wrong. It's just that not for the reasons that you said. Oh, Elliot, sorry. So when you sub in -3, I agree that -3 can be, but could you make your life easier? Elliot, certainly there must be something easier to sub in than -3. For example, I mean, you have done 0 and 1. Those are the two more easiest things. So, but there is one more guy, which is kind of easy to do.
Is it just 2?
You can do 2, I don't mind. You can also do -1, I don't mind.
Yeah.
Isn't 2 and -1 easier than -3? That's the point. That's the point. You should make your life easier, not harder. Right?
Okay.
Yeah, you can do 2, you can do -1. Just experiment whatever you feel comfortable. Okay, Daniel, are you looking for? What are you looking for?
Wait, can I ask a question?
Yes, please.
So, right, what affects how likely fusion is to occur? Like
fusion compared to fission. No? So you notice that in this slide, he say fusion is
what factors affect how likely it is to happen?
I mean, the slide is already hinting you fission only happens in the heavier side. You may think that makes sense.
It is, the more likely it is to have fission.
The easier it is to fission. Not likely, but easier. You can fission everybody, you can fusion everybody. But at a certain point, if you fission the heavier guy fission will give you energy. If you fission the lighter guy, the fissioning the lighter guy requires energy. So yes, you can, but you don't want to. It's not more likely or less likely, but it's more like who gives you energy, because in this case, they're being very practical. They want energy out of as a way of generating energy. So
likewise, the lighter it is, the easier it is to fusion.
Better fusion, because when you fusion them, it will also give you energy. The other way is the not light. So if you fission the lighter one, it will not give you energy. It will just require energy, which is so much trouble for, well, nothing, so to speak. So the word likely is not what I will use, but I guess B and D uses likely. So I would disagree with that, but I guess you can take it with strides. Okay, Elliot. So looks like you still like the result of 2 . Okay, sure thing. All right.
So it's neither B nor D also.
Sorry. Region around the maximum, right? So around the maximum, it's 56, right? Around the maximum is 56. 56 is so stable. So I already tell you it's part C. It's so stable that both fission and fusion is not likely to occur. Fission happens very likely, if I use that word, in the lightest region. That means we're talking about proton number 1 or 2. And fusion happens in the other extreme end, which is the uranium or even heavier. The more you go to the center, the more it is unlikely to do it, or the more it is unlikely to give you net energy. So the region around the maximum is the worst thing to do anything about, because it's so stable anyway. You won't get much out of it. If that makes some sense, I hope, because I don't want you to memorize this. One -2. Yeah, I would. I'm sorry. Why don't you do 2 minus 1, Elliot? Make your life easier. Why don't you do that?
Okay.
Why must be 1 minus 2, right? Make your life easier, right? That's the motto, right? 2 minus 1. Slightly easier. Okay? Find the easier way. Does that make some sense, Daniel?
Yeah, it does.
Another way, 56, there isn't much to release anymore. He already releases so much. The average binding energy, which is the average energy released per nucleon, is already so high. He has no potential to release anymore. Neither fusion or fission is a good candidate, lah, right? You can always do it, but it will require just more and more energy. He has already released so much. I guess that's how you can say it. No more energy to release. Okay, that's question 1 to 4. If you have more on this topic, we'll be glad to talk about it.
I have a lot more.
Doesn't seem like you're on solid ground for this chapter.
Yeah, 7.2 is a bit for me. I got
If
the
you want to
alpha,
talk
beta, gamma decays, like all the equations done.
We can talk about it.
Oh, mostly done, I would hope. But this part, like fission, fusion.
Hey, Elliot, what happened? It's done.
No,
Okay, sorry. When I suggest 2 minus 1, it's because the 2b plus c minus the b plus c. Oh goodness me, my friend, you make a lot of mistakes. Okay, Elliot, yeah, sorry, yeah. Oh goodness me, right. Okay, Elliot. Looking at the Jamboard, page 3, yeah. Come on, Elliot. First thing first is 2 minus 1. This is 1 minus 2, right?
Oh, yeah.
This is 1 minus 2. Secondly, you make another mistake. Is 2b plus c minus b plus c. I mean, to be fair, 2b plus c minus b plus c should simply be b, man. What's going on here? The c should have eliminated each other. You did some mistake here, lah, is what I'm trying to say. You should have used brackets. You didn't. Remember how you do it back then? 2b plus c, b plus c, and then minus, ma. It should have been 0, and it should have been b, ma. The reason why you make this mistake is because you didn't have any brackets.
Okay.
To fix them. Question 14. Okay, I'm going to make it bigger, Daniel. Are we starting for question 5? Is it? Sorry, are we starting from question 5? Sorry. Yeah, I'm not sure about question 5. Either look at the slide or we just Google it. That one, I'm not so sure. You know what? I'm just going to Google it. Urban 12, that's a reference. So the answer should be B.
112 of the rest mass.
Yeah, the rest mass. Here, they never say the rest mass, but well, B is close enough.
Okay.
Okay. Oh, yeah, Elliot. Okay, so you got it. Do check using the method I told you, yeah? Yes, now the calculator. Okay, so Question 6, right? This is
I think answer is D. If I remember what.
yeah, I think D is wrong. As what I have written here. I think D and B is wrong. Gotta get it clear first. Please get it clear. Yeah, important. It's important. Basic, yeah.
Isn't M the unit, the mega?
Yeah, M is mega. I agree. So I think C is correct lah. By the way, I think C is correct lah. But B and D is especially wrong because of this guy, no? This guy makes it wrong, and this guy makes it wrong, and the reason is here lah.
Why is it? I see what you mean.
Yeah.
It's funny how it seems like the C to the power of -2 just disappears.
Correct. Because it did not disappear. It was just times C squared. So it's wrong to just make it disappear.
It seems like, yeah.
But the reason is here. They were just lazy in leaving this C square. However, I think it's a great advantage now. We don't have to make it a number. It'll disappear once we do this. That one I kind of agree with what they do. If you understand it, it kind of makes our life easier. Is what I feel.
Yeah. I get the whole manipulation. Okay.
Elliot, did you check whether you're right or wrong?
Yeah.
Okay, wonderful.
Oh, I know this one.
5A seems easy for me, Elliot. Is this a homework, 5A?
Yeah.
I was hoping that you could skip to slightly harder ones if you don't mind, because 5A I think is going to be easy if you know how to start. Maybe you just show me your starting step. If I think it's correct, maybe I would persuade you to go to something harder. And you can do it by yourself. If your first step is wrong though, then maybe let's do it. Okay, so we'll go to page 14 for question 7. Yeah, right, so question 7 on page 14 is already a familiar graph for you by now. You should be able to answer it. Give it a try.
A.
Yeah, 7A. 7A, I agree with the Y and I agree with A. Yeah, I just totally agree. Right? Okay, that's great. Now, question 8, if you would try. Your first step is correct, Elliot. I don't think you'll face any trouble, right? Yeah. Can we try something harder? Okay, I think you're on that level.
Okay.
So your question 8 is C, really?
Because alpha particle is the -4, -2, right?
No, minus, no. 4, 2 plus 2. Hello. 4, 2 plus 2. You should memorize that.
No, it's not -4.
No, I'm not even sure what -4 means. That means it's minus 4 nucleon. How does that compute? How can there be -4 nucleon?
4, 2.
Right.
The plus 2
4.
comes from where?
Oh, because he loses 2 electrons. So it's a 4 nucleon, 2 protons. So 2 proton, 2 neutron. And for some reason, alpha particle has lost its 2 electron because 2 protons should come with 2 electrons, right? But the alpha particle don't have that 2 electron. Usually doesn't matter much in physics. So try again, Daniel. There's a proton. Yeah, okay, there's a proton. So I think the proton will be important here. The electron about alpha particle losing the electron doesn't matter much here, yeah? Doesn't matter much.
B?
Okay, to test you, yeah, Daniel, what is the proton number of proton?
What? 1.
1, yeah, correct. The nucleon number of proton?
1.
Correct. So, correct lah. 4 plus 4. Okay, 14 is 18, no? 18. Then your answer is 17, ma? Correct, no? 17 plus 1 also 18, no? Correct. Then the bottom one, 2 plus 7 is 9. 8 plus 1 is also 9. That's why your answer B is correct. Do you understand?
So you ignore the alpha particle, basically.
No, I didn't. No, I didn't. I just ignore the charge of the alpha particle. Look. 14, 7 should become X. Your answer is 17, 8. I agree because plus proton 1, 1.
Oh.
I didn't ignore it. What do you mean? I
didn't.
I didn't. I shouldn't. What?
Sorry.
Yeah. So like that. Elliot, a harder one. Good. Now, Elliot, let me ask you about this. Yeah. This is supposed to be homework also, is it?
Yeah.
Okay. Then my question is, you have done long division in partial fraction or not?
Yes.
Should you long division here? That's the question. Should you or not?
Yes.
Why must we do that?
Because because the degree is the same.
Yeah, correct. The top is x cubed. The bottom is also x cubed. You can see that quite easily, correct?
Yeah.
Now, my question is, Elliot, what happens if in exam you forget about this and you didn't long division, you just go partial fraction immediately? Do you know what will happen?
No.
Let me tell you, this is a very short answer. Because the degree is the same, right? The degree is the same. This is an improper fraction, so to speak. If you try to partial fraction this, everything will be wrong. It'll give you nonsense. Then you'll be very frustrated in exam. Meaning to say, partial fraction only happens well, only can be done well when the degree on top is lower than the degree on the bottom.
Okay.
So if this happens in exam and you forget, even though you might have wasted some time doing it, but remember to check lah, and immediately go to the correct graph lah, which is to long division.
Yeah.
Okay. Now, my first time seeing you long division. Let's see. So Daniel, how about question 9? Binding energy, right? It's the same thing.
Yeah.
It's the same thing. Okay, right, sure. Okay. If there is some other questions.
There's a lot of questions. I'll put on the next page.
But are you getting more understanding? That's what you want, right?
Yeah.
Good.
I feel a bit more confident.
Mm-hmm.
Okay. Huh? Hmm.
I'm going to make it bigger, yeah? All right, finally, mass defect, right? Mass defect, finally. So I guess the question is, what is mass defect? According to you, yeah, not just the definition. The long division. Oh, okay. I see what you mean, Elliot. I see what you mean. You're preparing for it. Okay, I agree. I agree with your. Okay, I agree with your. He the example does not explain to you what the mass defect. Okay, never mind. I'll try to explain. Okay, Daniel. Right. Then maybe you can understand the slide better. Okay. Would that be okay?
Yep.
Daniel, can you hear me? Sorry.
Yeah, can you hear me?
Okay. Yeah. Okay. Now I can. Okay. Mass defect is simply mass loss. So there's some mass which is lost. The mass loss is not insignificant. It's something. Now, when we say mass loss, it's not like we're going on a diet. Then we lose some mass through burning stuff, right? Well, I guess you can say that. Oh, that's not bad. Okay, I'll use that analogy. So when you go on a diet, I imagine that you are a very healthy person, right? You do kayaking, right? So instead of losing mass, you probably want to gain mass in the form of muscle, right?
Mm-hmm.
Right. But in the case of a fat person, he really wants to lose mass. So he go and burn the fat, which is, I guess still not a very nice thing to. There's always a problem. Never mind. I don't want. Okay. The point is, when you let E equals to mc square, you suddenly have the tool to change mass to energy. However, the implication is when you change mass to energy, you gain energy at the expense of mass. So you lose some mass in order to gain some energy. The guy trying to exercise to lose weight is doing it slightly differently. I want to lose mass, so I burn some energy. The point is you can convert mass to energy with the effect of losing some mass and gaining some energy. The other way also can. When you lose some energy, you can gain some mass. Also possible. That's at least possible in the realm of fusion and fission. I guess no other realm is possible to do this. That is the mass defect, the mass that you lose because you have converted some of the mass into energy. So far, so good.
Yeah.
Now, here's the kicker. Not done yet, yeah? That's the kicker. When you put a lot of protons and neutrons together, not by fission. I mean, you know that, for example, oxygen is what is oxygen? 18.8, I think. 18.8, right? So you're putting 18 nucleons together. Those nucleons lose some mass when they are being put together, and that manifests as the binding energy release. The binding energy release is because when they bind together, they lose some mass. That is the physics. The binding energy release implies that there is some mass loss when the nucleons stick together. Such is the definition. The mass defect is the difference between the total mass of its constituent and the mass of the nucleus. What is he trying to say? My goodness. So the nucleus is thinner because the nucleus implies that the nucleon gets together. Man. So when the nucleon get together to form a nucleus, the total mass is thinner compared to if they would just stay apart, stay individual. Any questions?
Kind of.
Since you know that mass defect means mass loss in order to, not in order, and it becomes energy release, then question 10 should at least be quite easy. Should at least be quite easy. You have to deal with the unit. The long division is obviously great. Yeah, obviously great. See how you handle this one. Surprise, surprise. Okay, Elliot, I was surprised that you didn't do the other technique, but what you did is absolutely great. It's correct. Okay, let's do. Yep, that's good. Now, Daniel, any question, or how about question 10?
I still don't really understand.
Okay.
So when you say what's the point of having a mass defect?
Not having a mass defect. No, that's not. There's no point if that's what you mean. You don't know what's deuterium, right? Doesn't matter. The point is, okay, I'll say that deuterium. Let's pretend that deuterium is 20 nucleon, right? Let's pretend. Okay, so you have 9 protons and 11 neutrons coming together to form deuterium, right? The total mass here separately is bigger than the total mass when they combine. There is no point. That's what happened. That's the physics. It is what happened. And this reduction in mass doesn't mean that the mass can just go willy-nilly nowhere. No, the mass don't just disappear. The mass will become binding energy to release. The mass is released in the form of energy. That's the point, I guess. When they tell you that the mass defect for deuterium is this amount, he is referring to the mass that he lost when the nucleons form together to form deuterium. Right? So if it is the mass loss, then the mass loss becomes energy. That's just like that. I just have to convert this mass into energy. That's what happened, I guess. We can say that. You don't even say that famous equation, so that worries me a bit. The famous equation to convert mass to energy, vice versa, is
E equals mc squared.
Wonderful. And you have the m, right? You have the m here in kilogram. You have the c squared if you need to. And therefore, you will have the energy. That's how you will do it. The only issue will be the units now. The units is a little bit wonky to work with. That's the learning in question 10. Would you
can't
please
use
give me a
kilograms anymore?
Or
to convert kg to a unified mass.
You can do that if you want to. Which they tell you here, right? No, they didn't. Oh, yeah, they did. You can use unified. Because unified immediately converts to MEV. I guess that's the benefit, right? When you will become 931 MeV, right, over C squared, which is very beneficial. Also, from kilogram, you can go to 1U. So this is something you want to use. This is the point of the question, I think. We'll force you to practice this. Give it a try. I need to see your working if you don't mind. Go to Jamboard. Easier to help.
Okay.
In is not, yeah, okay, there you go. Everything is not nice.
You just erased all my working. Oh,
No, it was something else. It was here, very likely. So, Elliot, are you concerned right now?
No.
All right.
No, sorry.
Okay. I mean, everything looks great. I don't know whether C is right or wrong, but everything looks great until now. The processes are fine. It's great.
Uh-huh.
Oh, okay. Right. So go back to the slide. Just go back to the slide. I'll copy paste it and explain it to you.
The answer is not anywhere near.
Yeah, I know. So I agree with your first conversion. Your first conversion is, sorry, my Jamboard also lagging. I have to refresh first. I still cannot see your working fully. Okay, your first conversion is the 4, right? So the 4 times 10 to the power minus 30 over 1.66 times 10 to the power minus 27. So this will convert from kilogram to U, right? Right. So now you have your unit, still a small atomic mass unit, but we have our U. I'm writing something on the Jamboard and I don't think you can see how they. So your first conversion is to change kilogram to U. Am I correct so far? That's the intention. Daniel, can I have some response?
Yeah.
Right. So now in your slide, he say 1U can also become this almost immediately. This is like so convenient. 1U is that, right? So I'm going to do that. I'm going to times 931.5 MeV over C squared. Don't forget C squared. That will be my mass. I convert to MeV over C squared. It's still mass. It's not energy, it's still mass, because then I times C squared. I times C squared, and then this and this will cancel each other again. That happened. The wonky thing here is the new unit. I hope you will try to understand this.
Okay.
Give it a try, see whether there's an answer or not, and then try to work it out. Oh, in question 11, I guess question 11. Yeah, maybe question 11. Keep repeating question 12, isn't it? Wow. Why do you put 0? Yes, I can understand why you put 0. Okay, Elliot, I have a question, yeah? The 0, I kind of agree with you. I kind of agree with you. How come, however, you never try minus 3 over 2? You don't have to, it's troublesome, but there are some advantages in x equals to minus 3 over 2. You know what the advantage is?
No.
All right. I would like to say first that what you're doing is correct. You can just do 0. You can just do -1. There's no problem with this. So maybe I want you to continue first and then go and check whether the answer is correct. And then we'll go back to x equals to -3/2. I'll try to explain what the benefit is. Okay? You do you first. What you're doing is not wrong anyway, and it seems convenient. So I'm all up to it. Yeah. All right, Daniel, are you okay so far?
Yeah.
Try question 11 then. You need space, isn't it? Let's give you space. Yeah, I'm trying to give you space right now. Okay.
Oh, the convert. Yes. If you can.
Giving you some space. There you go.
So how does yours?
I'm sorry, your question is?
Is it what divide by?
You're not using EMC square, you're not writing something. Are you sure you can do it just inside your mind? Are you sure? I mean, I don't mind if you can. I don't mind. Do you also know what's the mass of one proton? Do you know that?
What?
The central theme in this topic is that mass can convert to energy, vice versa. So when they ask you what's the energy equivalent to the mass of one proton, you can read it as, oh, I'm going to convert all the mass of one proton into energy. Again, using EMC square. I suppose you need the mass of the proton first before we can continue. If I'm not mistaken, in your formula booklet, they will give you the mass of one proton. I suppose in your slide, they should give you also. So what is the mass of one proton? You do need to find it. It's not
in the mass of one proton.
Do you think that you need the mass of one proton?
Yes.
Oh, I'm sorry. You're still doing question 10, is it? I'm sorry. I thought you were doing question 11. Sorry.
No, but question 10 answer was wrong even after we multiply in the thing. So this is the U, right?
That's the U, yeah. Which if you time that, time 93145, then you become some NDV.
Yeah, that's what I'm doing.
Right. Okay.
That's 931.5. Okay. And you get 2.244578 MeV minus 2. Then you multiply this times your C minus 2. So times 3 times.
Yeah, I mean, I think the answer is C. Oh dear, why do you keep timing the C square? I thought you made that mistake before. You're making it again. You're making it again. Come on. The reason is always the same. The reason has been the same. Come on, man. Look at that.
Yeah, it's already over 2. That means to get rid of this, I have to multiply it in.
Yeah, so this is C squared, right? And because the formula has a C squared, so this kind of just cancel each other, right?
Don't you have to multiply this in for it to cancel it out?
Look, this is over c squared. This is c squared. C squared over c squared cancel each other.
What?
C squared over c squared cancels each other.
Why? No, but
C
it's not in
squared.
this is not in the equation yet. What you have to multiply in so that the c square can cancel each other out.
Look, the formula is here. I'm using it, the formula already. The mass, which is here, right? The mass, this is the mass, right? The MEV over c squared, right? The mass is inside here. That's the mass. So the mass here is 2.24 something, right? MEV over c squared, which don't put the number in. When you put the number in, you don't understand the convenience that he's giving you. Don't put the number in, because then the formula have times c squared here. Bam, bam. That's the convenience that the thing is providing you.
Oh, okay, got it.
Right, okay. So there is some answer there, I believe, that fits this, right? I think they just round it off. I just round off the answer.
Okay, sure.
Right. Your answer will be then? Your answer will be?
Yeah.
I would agree with you. We are both right or we are both wrong. No? How is it, Elliot? Is your answer correct?
Yeah.
So your C was correct, right? 12 over 5 doesn't mean that you're wrong. You are correct. Okay? So, this should give you some confidence in exam. Hey, why is my answer so ugly? Yeah? Doesn't mean that it's wrong. I can always confirm it later. It makes me happy. If I'm... Now I'll show you minus 3 over 2. Could you please show me your working? Then you could try question 11. Yeah. Same formula, same principle. Right. So why do I say that this is advantageous? Because so that is the advantage. Do you see that, Elliot? This will be 0 and this will be 0. Don't you think?
I couldn't hear you at all. Like my Wi-Fi got cut off.
Right. So Elliot, can you hear me now?
Yes.
Right. So the advantage of x equals to minus 3 over 2 is that this is 0 and this is also 0. What do you think? Right.
Okay.
I can see you, yeah? The video can resume, yeah? So what happens when you put in minus 3 over 2? I think it's not that bad. You can use calculator. So this is a bit annoying, right? But you can always use calculator to help you solve. And then we have this one, minus 3 over 2 minus 1 squared, right? For learning sake, could you please solve this and see whether you get the same A or not? Can you do that? Yeah, Ines, just waiting for your video. Your setup shouldn't be long.
Yeah.
Let's continue from the one just now. Daniel, are you okay with the question 11?
Yeah. I'm a little bit stuck. I'll show you my working.
Please do. Please do.
Okay. Oh, I'll do on this page.
I think if you have space, that would be nice. All right, Aidesh. So yeah, okay, just to confirm, where did you get the rest mass of proton? Where did you get that? Just to confirm.
From the data book.
Okay, wonderful, wonderful. Right, and when you do that, you are left with EV lah. So this is the unit of EV, no? Right. Okay, wonderful. So is there something that is equivalent to this? No, no, no. Oh. It's the answer is C. So the conversion from EV to Joule, right? So you need to know the conversion from EV to Joule. Go and find that either in your slide or in your data book, even better lah. The answer is C lah, but you need to know why. So Ainesh, yep, let's go. So Elliot, what do you think? The A is correct, yeah?
It's like different, eh?
It's different. Whoa, cannot be. Cannot be. And you confirm that you're right somehow, right?
I haven't finished yet. But like I don't know how you can get this answer.
Then give it a try first. Ainesh, are you stuck or something? Sorry.
Yeah.
Yeah, I'll stop the screen sharing. Yeah. Should we stop the screen sharing? Yeah. I think we can just communicate using chat. Okay, Ainesh, I lost your video. Okay, it's do it. Make it landscape, please. So Daniel, are you saying zoom in, please?
What?
So Daniel, are you saying that you know how to change EV to Joule now?
Yeah.
All right. Then if you can, I guess that's the other learning here lah. Yeah, Ainesh, tell me where you are stuck. Yeah.
Yeah.
Well, because I don't think you should be stuck here, right? I don't think you should be. I mean, same process as last question.
Mm-hmm.
Do you know what to do now? Ainesh, come on. Do you know what to do? Elliot, how is it? Is it not correct?
I got 4.92.
Yeah, I also did. The original A should be
I
10.
got 10. For my A, I got 10.
Let me check one more time. Okay, you do some other question, I'll be doing checking. So Daniel, if you're happy with question 11, let's do question 12. Oh goodness me, question 12 please.
Okay.
Yep, you're using the GDC INS. Good. So remember, you're supposed to zoom out, right, to get the value.
Yeah. By 16.
After 4, right? Daniel, how's question 12 in the Jamboard? Sorry, are you doing it?
I'm at question 16.
You're at question 16, right? Which is
Yeah.
page 17, is it? Oh, you're doing it on paper. You're doing it on paper.
Yeah.
Sorry. Go ahead. If you have no question, then okay.
Yeah, no questions.
Right, good. Oh, you're good. Goodbye. Is this the last question of your homework, Elliot? Oh, okay. All right. No complaints then.
Uh, 16 is B, right? Just to double check.
Let me check.
Because
So,
helium is another word for alpha particle. Right.
201. So 4, right? Okay, 201. Okay, looking good. And then this is 81. And therefore this is 2 lah. Yeah, agree. So Ainesh, your answer, okay, I'm going to copy your graph because it's easier, right? Okay. So Ainesh, what do you think is the answer? Is this weird value?
Okay, I'm done already.
All right, Daniel.
Is this value plus this value? I don't know if you can see it, but
Which value?
I can't see it, but it's the distance between the intersection with the x-axis.
This one, is it? Yeah, this one, right? This thing, right?
Yeah.
I agree with you. Okay, good. Okay, moving on now. Maybe one more. Oh, it's 10 o'clock already.
Okay.
Well, that was fast. Okay. All right, Daniel, I hope you got something today. And I'll see you on Tuesday.
All right.
Bye-bye. Elliot, are you done with the last question?
Yeah.
All right. Hope you learned something today. And I will see you on Tuesday.
Okay.
Now,
All right.
same thing with you, Ainesh. Is this the last question of the worksheet?
Yeah.
All right. Hopefully you learned something today, and I'll see you on or tomorrow. Right? Tomorrow we'll continue with the OCAM. Right? Be fast and be sharp today and tomorrow. Right? Bye-bye.
Bye.